Assalamualaikum warahmatullahi wabarakatuh, and welcome to another video lesson for physics. Today we're going to look at something that is called stopping distance. So stopping distance is the thing that we want to look at when it comes to stopping a car. So we're going to talk about how cars going to stop in terms of like the calculations, and also we're going to look at the safety precautions or road safety when it comes to when you are driving a car and when you are trying to brake. So this lesson is all about how do you or what are the factors that you look into when you are trying to stop a car. Okay, hence the name stopping distance. Road safety. Stopping distance is important for road safety. Drivers have an increased risk of an accident if they are driving too quickly for the road conditions. So you know this by now. Driving too fast is bad. You need to drive at the right speed. It is especially dangerous if a driver tailgates, that is, drives too close to the vehicle in front. So stopping distance. To be a safe driver, you need to understand the factors that affect a car's stopping distance. So stopping distance can be calculated using this general formula. Basically, in order to calculate stopping distance, you need to add thinking distance with the braking distance. So we're going to talk about each of this very soon. So what is thinking distance and what is braking distance? Under normal driving conditions, the thinking and braking distance depends on the speed of the car. So the faster the car is, then the larger the thinking distance and the larger the braking distance will be. So I'll talk more about that later. So question, imagine driving behind a car on the highway, then the car in front of you suddenly brakes. Okay, so this normally happens when you drive a car. That's why you never drive too close to a car if you're behind a car on the highway. So in this situation, is it better to have a long stopping distance or a short stopping distance? So which one is it, right? So like I said, stopping distance is the distance you the distance the car makes when the car is trying to stop or when you are trying to stop the car. So is it better to have a long one or a short one? The answer to that is a short stopping distance is better, right? So you want to brake as soon as possible. You want to stop as soon as possible. Or in other words, you want to stop in a short distance. Okay, you don't want to stop a long distance or else you will hit the other car and you might injure yourself. So you don't want that to happen. So short stopping distance is better. Because you are about to crash into a car, it is better to stop as soon as possible. Yeah, this is what I explained. So what is the thinking distance? It is the time for a driver to react to a situation and start to apply the brakes. The car carries on moving during this reaction time. The thinking distance is the distance traveled in this reaction time. Right. So let's say you are driving, okay? Let's say you're driving, and then you see a person crossing the road in front of you very suddenly, right? So, and then you will react to it, of course, and you will want to press the brakes, hopefully, right? So the time it takes for you to see the person react to it and then press the brakes, that is your thinking time. And the distance while the car is traveling during this time is called the thinking distance. So do not confuse between the thinking time and the thinking distance. So thinking time is more of your reaction time. Okay, they are both related, of course. Your thinking time is related to your thinking distance, but one is time and one is distance. So do not confuse between these two. So the longer it takes for you to react and to press the brakes, the larger the larger your thinking distance. Okay. So you haven't pressed the brakes yet, you are thinking of pressing the brakes. Okay, so in other words, you are reacting. It's probably like 1 second or 2 seconds, depending on how fast your reaction is. So within that 1 second or 2 seconds, while you are thinking of pressing the brake, how far your car has traveled, that is the thinking distance. The thinking distance increases if the reaction time increases. This can happen if the driver is tired. So if you are tired, then you will react slower. If the driver is distracted or not concentrating, so if you like texting your boyfriend or girlfriend while driving, so you're gonna not going to notice the person crossing the road in front of you. So your reaction time will be longer, and therefore your thinking distance will be longer as well. Under the so if you're under the influence of alcohol or other drugs, so if you're drunk or um, high, so that's going to increase your reaction time, and therefore that's going to increase your thinking distance. The thinking distance also increases as the car's speed increases. So in other words, the car will travel further during the reaction time if your car is faster. So that makes sense. The faster it is, the further it will travel in a shorter amount of time. Now, what is braking distance? The braking distance is the distance taken to stop once the brakes are applied. So like I said before, you are thinking of pressing the brake once you see someone cross the road when you are driving. You're thinking of pressing the brake. So once you press the brake until the car stops, that is the braking distance. Okay, so the braking distance is how far the car has traveled while you are pressing the brakes on the car or while the car is decelerating. So that is the braking distance. So what's going to happen? Okay, so imagine you are driving, a person cross the road, or maybe an animal like a cow cross the road, and then you are first you react to it. Okay, that's your thinking time, and then your car will travel at a thinking distance, travel for the thinking distance, and then you press the brake, and then that's when the braking time or braking distance starts. Okay, so it's thinking distance first, that thinking first happens, that happens first, and then braking happens afterwards. The braking distance increases if the car brakes or tires are in poor condition. So if your brake is bad or your tires are in poor condition, then that's going to take longer for your car to stop. Okay. The road and weather conditions are poor. So if you have icy or wet roads, of course that's going to be a lot more slippery, and therefore your car will take longer to stop, or in other words, your car will travel a further distance in order for it to stop. Okay. The braking distance also increases as the car's speed increases. Okay, that is the same as the thinking distance. The faster your car is, the more harder it is for it to be stopped. Okay, that's the general idea. Right, so the difference between 60 kilometers per hour and 100 kilometers per hour is only 40 kilometers per hour when you are driving. But when you actually get into an accident, the difference is actually much larger. You might think that the speeds are not really that different, but the damage done when you are traveling at that speed, when you are hitting something, is quite larger. That's because the impact is directly proportional to the square velocity. Thus, when the velocity double, the impact quadruples. So this has something to do with kinetic energy. So I'm not sure if you have learned that before. So kinetic energy, that is the movement energy. It can be calculated with this formula, half mv square, where v is the velocity, right? And as you can see, because the velocity is squared, that means the if you double your velocity, you will quadruple the energy. So when you are in a crash, the energy is quadruple to your velocity, and therefore, hence, that's why the damage is quite bad. Even though the velocity difference is velocity between a slow distance and a faster distance is quite small. Okay, you don't have to memorize this formula for now. You will learn about this formula 3 chapters from now, so probably towards the end of the year. I just want to let you know that that's how velocity is related to energy. So that's the end of the lesson. To summarize, your vehicle needs stopping distance to stop. Sudden braking does not instantly stop the vehicle. So there's no such thing as you press the brake and the vehicle stop immediately. There's no such thing. You press the brake, the vehicle will travel for a while. When we press the brake and then the vehicle will make a sound like it. So that sound there, that's when the vehicle is making a stop, is trying to stop, and that's when it travels the stopping distance. To avoid car collision, it's better to have a short stopping distance and also to have a short thinking distance, and have a short braking distance. So stopping distance can be calculated using this formula, thinking distance plus braking distance. Thinking distance is the distance that the vehicle travels after the vehicle has seen the danger, after the driver has seen the danger and before the brakes are applied. And braking distance is the distance traveled by a vehicle after the brakes are applied until it comes to a stop. Okay? And that's basically it for this lesson. I'll stop there. We're going to continue again probably after the holidays. I'll probably see you, some of you, after the holidays. So in the meantime, do your work during the holidays and stay safe. I'll see you next time. Assalamualaikum warahmatullahi wabarakatuh. Thank you for watching.